In this PowerPoint, we're going to investigate the exact values of the trigonometric functions. There are two special triangles, the 30°/60 degrees triangle and the 45-degree triangle. Proceed to the next slide. Okay, here we go. We've got two triangles here. They're both right-angled triangles, so I'm going to put the right angle into the triangles first. Okay, this triangle down here has a 30-degree angle down the bottom right-hand corner, and because this angle sum of a triangle is 180 degrees, this triangle here is like that. Make this look a bit neater. This would be the 60-degree triangle, the 60-degree angle up here. So when we talk about the 30-degree triangle, right angle triangle, we're also talking about the 60-degree right angle triangle. And if we look at this triangle over here, that the angle down the bottom corner here is 45 degrees. And if you do your angle sum up to 180, then this also has to be 45 up here. So the 45-degree triangle means it's an isosceles triangle, which means that length there is equal to that length there, because the hypotenuse, which is over here, is the longer side of the triangle. It must be different length to the other two. Back over to the 30-degree triangle, the one on the left here. Okay, the simple fact to remember for a 30-degree triangle is if you look at the side opposite the 30 degrees, if you made that 1 unit long, which I've done there, 1 unit long, then the hypotenuse is always 2 units long. So it's the hypotenuse. Alright, so if we're talking about the 30 degrees, this would be the opposite, and therefore this side here would be the adjacent. Now, using Pythagoras, we can actually work out the length of this third side. So this side here would be equal to the square root of 2 squared, the hypotenuse squared, take away 1 squared. So we actually find that this length here is equal to the square root of 3. So they're the three special sides of the right angle triangle with 30 degrees in one corner and 60 degrees in the other corner. If it's the fact, remember, is the opposite, the 30 is 1 and the hypotenuse is 2, then we can work out the length of the third side by using Pythagoras, and it comes out to the square root of 3. And they're the exact values of this triangle. If I was looking at the 60-degree triangle, then this is still the hypotenuse of the right angle triangle, but this number over here, the root 3, would now become the opposite of 60, and the side over here on the 1 would be the adjacent to 60. So if it depends which of the two triangles we're looking at here is 60 or 30 down the bottom corner, depends where the opposite and adjacent is. Alright, if I go over to the isosceles triangle, the 45-degree triangle, we try and remember this fact here, that if this side length here is 1, because this is isosceles, that means the two short sides here are equal. That dash there indicates the equal sides. They're both 1 unit long, and by using Pythagoras again to find the length of the hypotenuse, it will come out to exactly the square root of 2. So they're the two special triangles. What we try and do is remember a certain fact for each one. Now, for the 30-degree triangle, the fact I remember is the opposite over hypotenuse is equal to 1 over 2. Look at the 30-degree triangle down, the 30 degrees down here. Opposite is 1 and divide by 2. And we already know that opposite over hypotenuse is sine, so the fact that we remember here is the sine of 30 degrees is equal to 1 on 2, or a half. That's a pretty simple fact to remember. The sine of 30 degrees is equal to a half. When we get to the 45 degree triangle, we can see the easy thing to remember here is opposite the 45 is 1, and you'll notice if I went this way, opposite 45 is still 1, and if we're concentrating on this 45 degrees here, this would be the adjacent side. So we got the opposite over adjacent is equal to 1 over 1, which we know is equal to 1, and therefore we can, the simple fact that we should remember to help us to remember these triangles is the tan of 45 degrees is equal to 1, and by using Pythagoras we can work out the third side. Most people will try and just remember the three numbers together, so over here we've got 1, 2 and root 3 is a triplet or a triad, and in the 45 degree triangle we've got 1, 1 and root 2. They're the two triangles that we need to learn about and remember. Not too difficult to learn these if you stick to a few basic facts. And the two basic facts that I use to start with is sine of 30 degrees is 1/2 and tan of 45 degrees is equal to 1. Okay, we'll stop on this slide here. Okay, I'm going to try and recreate those two triangles from scratch without having anything in front of me. So initially I'm going to start with the 30 degree triangle, so I'm going to draw a right angle triangle like this. I'm going to put 30 degrees into one of the corners, doesn't matter, and therefore that would be 60 degrees up here. Alright, so that's your first thing. You draw the triangle with the 30 degrees in it and mark the other side. The one fact I said you should try and remember is this: sine of 30 degrees is equal to 1/2. So sine is opposite, so here's the opposite, over hypotenuse, so 1 on 2. Using Pythagoras, or memorizing that the third side of this triad is root 3, I get the triangle. From this, I can now work out 6 exact values. They are for sine, for cos, and for tan. I can work out what their exact values are for two different angles, 30 degrees and 60 degrees. Sine of 30 we've already said is 1/2. Cos of 30, cos is adjacent. Alright, so for the 30 degrees triangle this would be the adjacent, and this would be the opposite, and this would be the hypotenuse. So cos is adjacent over hypotenuse, so that would be root 3 on 2. Tan of 30 degrees is opposite over adjacent, which is 1 on square root of 3. And if we remember from our third work, we can rationalise this denominator by multiplying by root 3 over root 3, so it becomes root 3 on 3. The 60 degree triangle, I'll change colours here, so if I'm starting to do the 60 degree triangle, then this now becomes the opposite, because that's opposite 60 degrees, and this here is the adjacent to 60, so if I wanted the sine of 60 degrees, I go opposite over hypotenuse, so that would be root 3 divided by 2. The cos of 60 degrees is the adjacent, so we're looking at 60, the adjacent side is 1, and the hypotenuse is 2, is 1 on 2. And the tan of 60 degrees would be the opposite, which is root 3 divided by 1, so it's just root 3. Okay, some interesting things showing here. You'll notice that the sine of 60 degrees here is the same value as the sine of cosine of 30 degrees. These are called sine and cosine for a very good reason, is they're very, very closely related to each other. They're like cousins, cosine and sine, and actually the co stands for the complement of sine. So what we find is the sine of 30 degrees is the same as cos of 60 degrees because we're talking about the same triangle, because the 30 degree triangle is the same as the 60 degree triangle, and vice versa, that the sine of 60 degrees is equal to the value of cos of 30 degrees. Tan is related to these two in another way, which we'll discuss in further lessons. Alright, so there's a way, by remembering this one fact, that sine of 30 is 1/2, I can get 5 other exact values without having to memorise them off by heart. Let's see if we can do the same for the 45 degree triangle. So the 45 degree triangle, we'll draw this. Okay, it's a right angle triangle. This is 45 down in here. And if that's 45, then this angle up here has to be also be 45 because the three angles in a triangle add up to 180. Therefore, this is an isosceles triangle, but this side's equal to this. So this length is 1, this length is 1. By using Pythagoras, I can work out that this length here is the square root of 2. Alright, from this triangle we actually only get 3 exact values. So for 45 degrees, I can get the sine of 45 degrees, the cosine of 45 degrees, and the tangent of 45 degrees. Alright, so it doesn't matter which 45 I picked here because they're both going to give the same result. So I'm going to use this one here. So this going across here, this would be the opposite. Down next to it would be the adjacent. And this is the hypotenuse because it's opposite the right angle. Sine is opposite over hypotenuse, which is 1 on the square root of 2. By rationalising our denominator, that's also the same as root 2 on 2. So the exact value of sine of 45 degrees is the square root of 2 divided by 2. Cosine of 45 is the adjacent over hypotenuse, so the adjacent over hypotenuse, so it's also going to be 1 on root 2, which can be simplified to root 2 on 2. Both the same answer. Tan of 45 is 1 divided by 1, so the tan of 45 is 1. So that's the fact that we try and remember off by heart. Then I can create these two triangles. So the tan of 45 is 1. Some people will just learn these 9 things off the top of their head. Either way, you need to learn them. These are the two triangles which are now nice neat diagrams. You can see that the 30 degrees written up here doesn't really matter as long as it's a right angled triangle, and the third angle must be 60 degrees. Once again, sine, which is opposite, over hypotenuse, that's the hypotenuse here, is equal to 1 on 2, and therefore I can work out all the other ones. The square root signs, we'll just extend those like that, make them look like square roots. Okay, and the 45 degree triangle, we've got the 1 and 1 being the two short sides here, and the hypotenuse equaling the square root of 2. And from these we can create our table of exact values, which you'll see on the next slide. We saw from the previous slides that the sine of 30 degrees is a half, the cos of 30 degrees is root 3 on 2, adjacent over hypotenuse, and tan of 30 degrees is 1 on root 3. Now keep in mind the next slide will have this all nicely, neatly typed out, or that's root 3 on 3. At 45 degrees we found that this was root 2 on 2, or really started off with 1 on root 2, and we can rationalise that. This was also root 2 on 2, and tan of 45 degrees is equal to 1. Okay, sine of 60 degrees we saw was root 3 on 2, opposite at 60 degrees, and the hypotenuse of the 60 degrees triangle, opposite 60 degrees, hypotenuse. Cos of 60 degrees is the adjacent side, which is 1 over the hypotenuse, and tan of 60 degrees is actually root 3 opposite over the adjacent, and root 3 divided by 1 is just root 3. Okay, there's some other values here we need to know the exact values of, and they're these, that the sine of 0 is 0, but the cos of 0 is 1. The tan of 0 is 0. Interesting, we talked before about how sine and cosine swap for the matching triangle. So sine of 0 degrees is 0, but sine of 90 degrees is 1. And look back over here, we can see that cos of 0 is 1. So we find cos of 90 degrees is 0. Tan of 90 degrees, so this is tan of theta up here, where theta is 90 degrees, so tan of 90 degrees actually doesn't have any answer, so we say it's undefined. Remembering it's very hard to do this with the mouse. Alright, if we go to the next slide, we can see the nice, neat values of these, which you should copy into your notes now. There are no questions from the textbook to be done for this section on exact values. What we want you to do, and what we need you to do, is to learn the exact values for these two triangles. Oh, that's not very good. You need to learn the exact values for the two triangles. So that table of values on the previous slide, we'd like you to memorize that in any way you can. Thank you.